Right, I think we're going to start now. So good afternoon, good morning, everybody. Welcome to our latest in a series of events we're putting on to highlight particular organizations within the OASIS community that we think have interest to all of you, hopefully. And today we have an organization that's based in Mexico called ERN, and you're going to see a few of the colleagues from that organization who are going to be with us today. And I have to say, when I started OASIS 10 years ago, ERN were one of the companies that it was at the top of my list of, there has to be a way to get companies like ERN to more easily make their services and their products and their knowledge available to the insurance and reinsurance community on a global basis. And a few years before that, I'd met Mario and some of the team from ERN in Mexico. And actually, we'd done essentially some analysis of the ability of their models to answer questions for the organization I'd been working for. And one of my colleagues who I was working with then, who I probably shouldn't name because of where he works now, but anyway, he came back and he said to me, he said, Dickie, there's no possibility that anybody can know more about Mexico City and Mexico and earthquake than the team at ERN, which I thought was a great way to be introduced to some of their capabilities. And today we hope to share some of that with you. So what else should I say? I think the Mario and the team are going to talk a little bit about the products they've got and what science they're bringing to the table. But I think it's worth noting that I think probably the ERN as a company was pretty much the first successful spin out from a university. There aren't many that have actually achieved that. Macquarie and Risk Frontiers in Australia is one. You could say Fathom, I think it's probably a more recent one in the UK from Bristol for flood. But I think that probably ERN is the first one. And there has some benefits, which you're going to hear about shortly. And of course, all of their models are available in OASIS. And that brings efficiency and consistency. So I think that's probably what I'm going to say, apart from we are recording this just because it's useful to make sure that we capture questions and comments. And on the questions and comments, please, if we can, we'll make this a little interactive. It's obviously difficult doing that virtually, but you can put stuff in the chats. You can send them directly to me. You can send them directly to the ERN team. I'll try and pay attention to that and monitor those. And I might occasionally interject to give Mario and team some of those questions. And if anybody else doesn't, I might ask some. So with that, thank you all for attending. Thank you to the ERN team. Mario, over to you.
Thank you very much, Dickie, for your kind introduction. Good morning, good afternoon to all of you. Good morning, Mexico, and good afternoon in London or wherever you are. Thanks for coming. Let me share my screen. Can you see my screen now?
It's perfect. Yep, you can see it perfectly.
Okay, thank you very much. So we will take a few minutes to present to you some recent developments that we have had here at ERN. First, I will start with a brief history of the company. Then I'll show you our new subcontinental Latin American model for earthquake, which we call ASLAC. Then I will show you a few slides on a very interesting work we have done recently, which has to do with recalibration of our Mexico earthquake model in view of the occurrence of several important earthquakes recently. Then I will also spend a few minutes showing to you our pan-European earthquake model, which is also available in OASIS. A few words about a new tsunami model we have recently released, and finally I will comment on other activities that we've been developing. So let's start with a brief history of ERN. As Dickie was saying, ERN was born in Mexico City as an incubated enterprise of the Institute of Engineering of UNAM, the National Autonomous University of Mexico. And it started as an earthquake modeling company. In 1998, we created our first seismic risk model, which was at that time the first one which included vulnerability functions with physical basis and not just purely empirical basis that was the costume at that time. And that system has been used since 1998 for insurance regulation in Mexico. So since 1998, the insurance regulator requires to build reserves at amounts which are dictated by rounds of the risk model. So the reserves are more or less coherent with the risk that actually the insurance company is carrying. Now in 2005, right after Hurricane Vilma in Mexico and the Caribbean, we constructed our first hydrometeorological risk system, which in 2008 started being used also as a model for insurance regulation since 2008. Also around 2008, we at ERN, we designed CAPRA, which is it's a software for risk calculation. It's a generic risk calculator, which was, this was a World Bank project and also an IADB and a GAR United Nations project. This system it's been widely used for teaching risk and to do some risk calculations. It's an interesting peril agnostic system that we still use. In 2009, together with the Institute of Engineering at UNAM, we developed a system called RFONDEN, which we built for the government of Mexico for the estimation of losses due to several natural hazards for the property of the federal government in Mexico. So FONDEN used to be the National Catastrophe Fund, and we gave FONDEN tools to do a more rational risk analysis. 2012, we made for GAR, the Global Assessment Report, we made the first standardized global study of seismic hazard for the whole world. Also in 2015, we developed the first version of our earthquake risk model together with the Italian company RED. Since 2015, together with this same company, RED, we were appointed in 2015 risk management specialists for CRIF, the Caribbean Catastrophe Risk Insurance Facility. And we built the SPHERA model for together with RED for CRIF, which is the model that CRIF uses to operate its parametric products for earthquake and hurricane. 2017, we released the first subcontinental model for Latin America and the Caribbean, harmonized and state-of-the-art. I will discuss this later. 2019, we were recognized by the magazine Reactions as the Risk Modeler of the Year. 2020, we developed a US earthquake model, which is now implemented in our systems. And then 2021, we built a parametric earthquake model to underpin insurance in the platform of the insurance company Super. And this is a parametric product which is already being sold in Mexico, and actually it has already paid some indemnizations during earthquakes. So this is a very brief history of ERN with some of the most interesting things that I think we have made. We have made work in about 50 countries in the world, which you can see here in white, and dealing with many types of perils and risks. Now, the first thing that I will discuss is the ASLAC model, which is an earthquake model, which you can find in OASIS. It is, I mean, historically, the Latin American and Caribbean region has had earthquake models or earthquake hazard models since many years ago. But the models were usually made to on a national basis. So the models were generally discontinuous at the borders because they were made for single countries. So a couple of years ago, we released the first version of fully probabilistic seismic hazard and risk model, which covers the whole Latin American and Caribbean region. It is a borderless model, so there are no political borders. There's a uniform approach adopted for calculation of probabilistic seismic hazard in the whole domain. It is an updated model, and it has been implemented in our systems as well as in OASIS computational engine. And let me close this. This is some highlights of the model. It covers the whole region. We've made a systematic review of historical instrumental seismicity, historical starting from 1502, and then instrumental seismicity for 20th century and later times. The model has more than 400 seismogenetic sources, which use different seismicity models or different occurrence models. There's a 3D representation of the subduction sources, very carefully made with the help of recently developed databases for the geometry of the subduction slab in several places of the subcontinent. We use different occurrence models or magnitude frequency relations. So we use the normal Gutenberg Richter as well as characteristic earthquake modeling in some places. We use what we call composite GMPES or composite ground motion prediction equations, which is a more efficient, numerically more efficient way to handle epistemic uncertainty related to attenuation or ground motion prediction equation. So we use this composite GMPES, which make the computations faster in what regards the propagation of epistemic uncertainty. There are some examples of the hazard maps that, of course, are a byproduct of our risk model. We don't use the hazard models for risk calculations, but we can compute the hazard models with the same at the same time that we do risk calculations. So here are some hazard maps. This is PGA for 225 years at the left, 975 years here at the center, and then some close-ups to Mexico, to Colombia, and Central America, Venezuela, the northern Venezuela, and the Caribbean. So this is the model we have included in the risk model whenever they are available. Urban soil responses, so there are many microzonations that are included in the risk model. Of course, Mexico City is the one which with a more refined microzoning and amplification, side effects amplifications. But there are several cities in Mexico and several cities in other countries for which there are microzoning studies. This, as you know, is much better, a much more reliable representation of side effects than the approximate amplification factors based on BS30 or other proxies. The model is fully integrated with a post-earthquake parametric tool, which can which we use on near real-time computations in the case of the parametric instruments that we that we operate with this model. This is an example of the September 2017 Tehuantepec earthquake, magnitude 8.2 earthquake in the Tehuantepec region in Mexico. So the model is coupled to this post-earthquake tool for parametric purposes. Of course, we've made validations, frequency validations, and also loss validations for different parts of the subcontinent, in particular for Mexico. And I will go to the next point to show you the work we've been doing in the last couple of years to recalibrate our model, essentially after the 2017 Mexico City event, which, as you know, produced losses in Mexico City and other parts of the country. So we started building an exposure database, which is representative of the insurance industry, of the Mexican insurance industry. The database contains about 1.5, if I'm not mistaken, million records of actual insured buildings. And this size is roughly the number of insured buildings in Mexico, the total number. So we think this portfolio is representative of the exposure, of the insured exposure in Mexico. You can see here the distribution of value of this portfolio state by state. So about 20% of the value is in Mexico City, and this is the geographical distribution, and the pie chart shows the distribution in terms of structural classes. So the portfolio is dominated by masonry buildings with 30% of industrial constructions and 21% of structural frames or moment-resisting frames. This is the database. We also built a database of reported losses or actual losses, total losses, and also losses for the insurance sector, using many sources of information. And we, of course, there's variability in the reported losses, either total or for the insurance industry. And so we have kept in cases where there's more than one estimation, we have kept the minimum and the maximums to see to calibrate the model. And since some events have taken place in the past, some years ago, we have also performed a loss normalization process in order to make comparisons in current dollars and with an estimation of the current size of the exposure. So we have studied 8 events that have produced losses of different sizes in Mexico. So we start, the oldest one is, of course, the 1985 September event. And we go up to the June 2020 event. And of course, we are including here the September 19, 2017 event, and also the September 7. So the Tehuantepec earthquake, magnitude 8.2. All these events produce losses in different parts of the country. So we are calibrating we calibrated our model against the losses reported for each one of the earthquakes. You can see here the three main events. So notice that the scale is 140,000 million pesos. Okay, so this is, and we have minimum reported in orange, maximum reported in yellow, and then the estimation of our model. These are the three events that produce the highest losses. And then we change the scale. Now we are in 12,000, so much lower losses, 1/10 of the losses here. And again, minimum, maximum, and estimated net loss for the insurance industry. So these are the results after several calibration operations. We also studied another 8 events which were recorded and had some importance, but didn't produce losses or produced very small losses for the insurance industry. Now we are in something much smaller than in the other scales. So these are much smaller events, but it's also interesting to see how the system performs, the model performs in earthquakes that produce very small losses. So for of these earthquakes, 8 earthquakes, 5 of them had reported losses, which are compared here with the estimated ones. And there are other three events for which there were no reported losses, but the system computed a small amount of losses here. So in general, the geographical distribution of the estimated losses by the model are coherent with the earthquake size and the truly affected area. Here is, for instance, the 2017 event that hit Mexico City, Puebla, and some other places in the epicentral region. Here we have the 2010 Mexicali earthquake that also produced heavy damages in the country, etc. So the comparison is good both in terms of geographical distribution and size of the affected area. This is a final correlation or a scatter plot of correlation between reported losses and estimated losses. The system is better calibrated for large losses, and there are some instances in which some losses are computed without reports. So, but in general, we think that we have a better calibrated model than we used to have before this effort. And now we are already working in calibration for other countries, some examples of calibrations made for Costa Rica and Haiti, and we are working on that. So that was our the second topic. Now let me move to our third topic, which is a brief panorama of our European model. It's again a borderless model, continuous coverage for 44 countries without adjustments along borders, so hazard is uniform. It's based on the share hazard model, which was a European Union project. I think this is the first commercial model that fully implemented the share model. We have an up-to-date exposure database, very carefully constructed, and state-of-the-art vulnerability model. And it's as the other models of ERN, it's very versatile. You can find it in our platform, which it's called System R+, and also you can find this model in OASIS. It has a stochastic catalog of about 2.8 million events, from which a seismic hazard map can be constructed. This is an example. So it's a pretty state-of-the-art model. Vulnerability curves, which are different or are differentiated by country, material type, lateral load resisting system, code compliance, which is highly correlated with the age of the building and height of the building. So it has a fairly rich set of vulnerability functions. it can include multiple coverages, so structural, non-structural contents and business interruption computed in a simplified way, business interruption. It has vulnerability functions for buildings, but also for infrastructure and other industrial assets, for instance, bridges, cranes, storage tanks, etc. So it can be used also for calculation of risk in industrial assets. And it considers several lines of business, residential, commercial, industrial, public buildings, etc. It has been also calibrated against several earthquakes. You can see here the scatter plot correlation, the scattered correlation plot. There are several well-known European earthquakes against which the model has been calibrated with a reasonable capability of reproducing observed losses in the past. And this is it. This model is also available in OASIS platform. Then I go to our new Tsunami model. It's a model linked to our ASLAC model, so it's linked to the earthquake model of Latin America and the Caribbean. And it uses as input, of course, the synthetic earthquake catalog generated by the ASLAC model. And then, we take the earthquakes from that synthetic earthquake catalog, and then we do the wave propagation through the ocean using GeoClaw, which is an open source, very powerful tool to do the numerical modeling of the propagation of waves. And the model's output is a very large stochastic set of tsunami effects measured in terms of wave heights at many receptors along the coast. So the earthquake is generated here. This produces a dislocation of the surface of the sea, which translates into a wave that can propagate for very, very long distances, and finally reaching the coast and producing floods or inundations up to certain portions of the coast. These calculations are made, these are the tsunami generating sources of our model. It includes sources in the Pacific coast and also in the Caribbean. And then these are examples of some earthquakes, some events, synthetic events, and the wave heights that they are producing as a function of time. So you can see how the earthquake, for instance, starts here, somewhere here, let's see, and then the waves propagate. You can see diffraction here and other features. Here's the earthquake starting and the waves propagate, etc. So there's a fairly large set of these events. There are many receivers along the coast, so we can compute the height of the tsunami and then produce, for instance, hazard maps or risk calculations based on the tsunami heights in different places of the coast. These are some examples for Mexico and some examples in a larger zoom for also the coast of South America, Central America, and some places along the Caribbean. Final topic I would like to present to you is some other activities that we have been making in the last years. We have kept with the development of parametric products. In the case of CRIF, the Caribbean Catastrophe Risk Insurance Facility, we have designed and we operate the earthquake models, the tropical cyclone, the excess rain, the fisheries product, and the power, more recently, the power utilities product. So we have built the models for these products, and we also are the calculation agents for the parametric policies of CRIF. We have a new assignment with CRIF, which is the development of a model for water utilities, so to make parametric instruments for water utilities. We have recently finished the development of a parametric product for landslide in the city of Manizales, Colombia, in partnership with Global Parametrics. And as I briefly mentioned before, we are powering a parametric product sold in Mexico by insurer Super, which is an earthquake parametric model, which is being sold as already, and it has even paid some indemnizations during earthquakes. So it's a very brief panorama of the things that we are doing. We try to give you a general indication of the type of things we have done and the type of things we are doing at present. And then we wanted to leave some time to discuss things or to answer questions in case you have. This is the end of my presentation. I thank you very much for your kind attention.
Mario, thank you very much. That was brilliant. Now I've got one question on the chat here, which I'll just say to you because you hadn't had time to see it. And it says, can you hear me all right?
Yeah, I can hear you.
That's fine. So the question is, do you plan to incorporate ESHM 20 to the current model anytime soon? You might have to say what that is, because I don't know what that is either. But
I think that's the new hazard model for Europe, right?
Right. That's probably, yes, it is. I think.
We are now in the process of getting the information from the people that built that model in order to translate it into the format in which we can read event sets. So we are
right.
That's in our plans. Yes.
That sounds good. Okay. One more question direct to me was on the parametric tool you discussed. Is that available for license?
Yeah, in principle it is. Yes.
Okay, that sounds good. I've got a third one, which is, and actually this might apply to others. Somebody said, the group here is interesting, the people who have dialed in. It's not some of the normal people we see, which is good news because that's part of what we're trying to do. But somebody asked a bit more about OASIS. So just a couple of questions, answers to that. So OASIS is owned by the insurance reinsurance industry. It's not for profit. And we have about 17 model providers from around the world, of which ERN is one. It's owned by the insurance reinsurance industry. We have consistency on things like our financial module, and we got very flexible deployment options. So you can have it on a laptop or a Mac or in-house, or companies like NASDAQ who are on the phone, or in a cloud environment. So a lot of flexibility how you can deploy it. So anyway, that's just a little bit on OASIS. Anybody else wants to know more, you can just come to one of the team at OASIS afterwards. One more question here, which is validation. So obviously, well, validation and evaluation, we maybe put them sort of side by side. One of the big questions sometimes is, how easy is it for prospective clients of yours to get an understanding about how these models have been built? You know, how difficult or easy how can you help your prospects and clients validate the model? Because most places require some sort of formal validation. What can you do there?
Well, we have a team which is dedicated to, completely dedicated to do validation exercises with earthquakes, with events or tropical cyclones in general, or events that have already taken place in the past. So we do research to get reasonable estimations of the losses during those events, and then we compare them with the losses computed retrospectively with the model, right? And then we calibrate the model in the sense that we might change some of the components of the models, most of the time vulnerability functions, to be able to match geographically and structural type-wise the observed losses in earthquakes. In the most recent earthquakes, for example, the recent earthquakes in Italy, there are very detailed databases of the losses actually experienced by the building inventory. So we can get cuts by structural system, by region, by structural material, and so on. So we have a team that has just this job, to permanently validate the models against old and new earthquakes that take place. I think that's the key test for the models, and of course models are so heavily parameterized that there are many sets of parameters that can fit a given set of observed damages, but we also have theory and restrictions that reduce the possibilities of adequate parameters, right? That's what we do. We do this type of things permanently to keep the systems with a reasonable prediction capacity.
Yeah, and you know, having worked with you for quite a long time, I know that you and the team are very naturally very open individuals. So there's no like secrets of how you do things. You know, you
No.
all come, or most of you anyway, come from academia. You're used to publishing things and explaining the science because that's your background, right?
That's right. That's right. We have some secrets, but personal.
Yeah, no, I know, I get it. But I think that's good, because I think, you know, for people wanting to, you know, use your models, there is the availability, you know, because actually sometimes model validation can be a big barrier for people licensing models, just because they don't have the resources in-house sometimes to do that. So to know that they can tap into the information that you have or your team has, I think gives a lot of comfort. So here's another question that's just popped up. Could Mario comment on the exposure model used for the ASLAC model, databases, granularity differences between countries, Mexico versus other, and you got to do that in less than 20 minutes.
Yeah, well, of course, the best exposure database that we have is the one for Mexico, because we have benefited from the information provided by the insurance regulator in Mexico. And then the exposure databases so the general exposure database for Mexico, which is not the database of insured buildings, but the general exposure database for Mexico and the other countries, it has, I think, lumped values of structures or buildings, not individual buildings, but nodes lumped at, I think, 1 kilometer resolution. Okay,
right.
And in the case of tropical cyclone, that goes down, I think, to 250 meters in areas closer to the coast to be able to get better information for the storm surge height. No, yeah. And in the case of the database for insured buildings, it's a building by building database with a lot of information, including height, age, structural system, material, etc.
And just, I mean, because I know if you take, so look, I'm frankly making the assumption that from my very first comment that there's nobody knows more about Mexico than you guys because you've been working there for so long. But I mean, even though you probably haven't been working there as long in places like Colombia, for example, but you've been doing quite a lot there, right? So let's just assume it's not going to be as high resolution as Mexico, but Colombia or Chile, for example, or you've been doing work there for still some time, I think, right?
That's right. Yeah. I think in the case of Colombia, well, the micro zonation that we have for the city of Bogota, for instance, it has less empirical validation than we have for Mexico City, but it has the same resolution. So it's pretty high resolution. Although the side effects in Mexico City are more robustly validated because of the existence of the Mexico City accelerometric network, which has about 120 accelerometers that have recorded, I don't know, maybe 15, 20,000 recordings, which we use to give empirical validation to our site amplification factors. But in the case of Colombia, we also have, I think we have, well, of course, the main cities, Bogota, Medellin, Cali, are microzone, and the microzonation is included into our models. And then smaller cities too, like Pereira, Manizales. I think in total we have the 7 or 8 largest cities in Colombia. In the case of Peru, we have Lima and Callao, which concentrates quite a large value. And outside the cities, we resort to generic amplification factors. So we don't have the same or factors taken from VS30, less refined, but in most of the value is concentrated in the cities for which we do have the microzoning information. Yeah. And
just quickly, because I think there's a lot of people that are interested. And Chile, more or less the same, or?
No, in the case of Chile, I think I'm not sure, but I think we only have 2 cities there. So I think Santiago, which has not huge side effects, and Concepcion.
Right. Okay. Yeah. Okay, but I mean, I think I think the point is, hopefully, to the gentleman that asked the question, you've got deep knowledge and information in Mexico, really good in other places, and I think the point is it's you're working with the local people there too, right? This is not like you're a company based in I don't know, London or Paris or something that occasionally flies there to find out what's going on. You work with these people all the time.
That's right, and several people in our team, including myself and Eduardo Reynoso, we actually do research with those data that we later include in the models, right? So we are in very close contact with several instances in which knowledge is being generated. So that I think that brings state of the art to our models.
And, it does.
Yeah.
It does. So I'll just ask anybody's got any last questions, please just let me know. But I'm going to sort of just made a couple of concluding comments, and we've still got a couple of minutes for people who've got questions. So I think look, I've said this before, but I've worked with you for a long, long time, and your team as well. If those of you on the call today have interest in understanding about risk in the region that you've been talking about, which of course now is extended a bit, so it's really the Caribbean and sort of Latin and South America, you really have some unique insight in that. And if you're a small organization that worries about resource, we have partners that can help you get those models or the results, either get those models running or get those results of those models. There are lots of ways you can get this insight. So don't feel that you have to be a very large organization to be able to afford to run these models or even license these models. They're cheaper than alternatives, the big 2 or 3 anyway, and they're more transparent. They're much more flexible. You get the benefits of the OASIS platform, which gives consistency, and puts you in the same position of, AXA and Allianz and Swiss Re and RenRe and SCOR and many other people that are using the OASIS platform. So don't feel like you have to sort of think like it's going to be difficult to do these things. It isn't. Just send a note direct to Mario or his team, send a note to me or the OASIS team, and we will make sure we can give you some advice about deployment, for example, and the options there. And we can then hook you up with Mario and the team if that needs to happen, and help you navigate that, because the opportunity is really just too good to miss, if you ask me. Maybe I'm a bit biased, but anyway, that's my observation after 27 years in CAT modeling. So I think there's no more questions. I can't see any. No more. Anybody else got a question?
A couple of comments.
Yeah, go on, please do.
Thank you, Dicky. I think I forgot to mention our earthquake models have certain recognition in the area. 4 of them are currently being used for regulation purposes. So our models, earthquake models in Mexico, Colombia, Peru, and Guatemala are being used by the insurance regulators for the same purpose that the Mexican insurance regulator, which is to give a reasonable size to the reserves and to the speed at which these reserves have to be constituted. So 4 of them, 4 countries for the earthquake model, and our tropical or hydrometeorological hazards model is also used in Mexico for these regulatory purposes. And the final thing that we are very excited about is we just published a paper in Nature that you might be interested to read, in which we describe a model to compute how the direct losses, as the ones that the traditional models produce, how these losses propagate into the economy of a country and generate secondary losses, or what is called secondary losses. So losses due to job positions lost, or inflation, or other types of disturbances, economic disturbances that are produced in large events. So we are very excited about that. If you want, I can send you the paper, because we think that this method has a potential for being very useful also for the insurance industry, in order to do perhaps better estimations of indirect losses or secondary losses, or which in some cases are, as you know, much larger than the cost of steel and concrete of the buildings or factories that were lost. No, so we're very excited about that. We haven't yet put that into our models. It's the technique is just came out of the oven very recently, but we are very excited, and we think that has a lot of potential also for the insurance industry.
Well, I think that is very interesting, because I was in a meeting yesterday on a new initiative that's being sponsored by the Insurance Development Forum, which is called the Global Risk Index Initiative. But the line beneath that is people, planet, and prosperity. And we were having a conversation yesterday about how we convert the catastrophe models, if you like, into the secondary losses that you've just been talking about. So that group at least would be interested in doing that. And that's sponsored by Mark Carney, as in pretty well known these days, I think, and also the president of Aon are the key sponsors for that particular project. So that group, and I sit on a technical steering group, that group would be interested. But I think the other thing is, if you have any material on any of the things that you've just mentioned that you think is suitable to be sent to the people that registered for this event, we can do that afterwards. So for those of you that have attended, we'll certainly get you some stuff out there that will help. The offer from my team, and I'm sure from yours as well, of course, Mario, to help out, please take this up on that. And then, if people want to have a conversation more about any of these countries, we could possibly dive into one or two of them if that becomes of interest. So I think no more questions. Any more points you want to make, Mario, or anybody in your team?
No, just thank you very much, Dicky, for your comments and the opportunity to speak to your audience.
Always a pleasure. Thank you. No problem at all. So I think we'll close it for now. And thank you all for attending. Really appreciate it. Thank you, Mario, for your team. And we'll be in touch soon. Goodbye, everyone.
Thank you. Goodbye.